Hi, and welcome to this tutorial on metals from rocks. This is going to basically introduce the Reactivity Series. We won't do the Reactivity Series as much in this one. I just want to explain the concepts really. So if you remember from the last tutorial, we took bauxite, which is an aluminium ore, and from that we used the Bayer process to make. So use the Bayer process, if you remember, to make the aluminium oxide, and then we went on to make aluminium from that, and of course after that you can make whatever you want out of aluminium. So that was just a recap of the previous tutorials on metals from rocks. I think this is really interesting because most metals out there exist as minerals in rocks. Obviously the ones that don't, we can isolate just by panning or finding in lakes and rivers and things like that. And one particular one that springs to mind that most people know, and it's one of the most treasured metals, is gold. So this is an image of gold crystals, and of course that can be turned into many different things, and it's got lovely properties. It's not corroded easily, and it's, like I say, it exists on the planet in the pure metal form within rocks and as ingots and things like that. So it's one of the very rare occasions where you'll find a metal in its elemental form, unlike bauxite, for example, which is found as aluminium oxides and sulfides and things like that. So we have a little bit of a problem. We're all right if we've got gold because we can use it straight away. But if we haven't got gold, if we've got something like bauxite or chalcopyrite, remember the copper one from the tutorial, or even iron oxide from iron containing rocks, then we've got several methods to extract the metal from its mineral form. For example, this will be Fe2 or 3. Okay, so that'll be iron oxide, and that can be extracted. We've got several methods at our disposal. We can use electrolysis, or we can use some chemical method of reducing this iron oxide down, so we can use a chemical process. Okay. Now if we use a chemical process, then we've got to be able to react iron oxide in this case with something else, something that will make iron. Now I'm just going to introduce you to one particular example. Would be reacting it with carbon. Now this comes from the Reactivity Series, and I'll just briefly show you that. Just gives a bit more room, and then in the next tutorials we'll have a look at that Reactivity Series. So at the top, if you will, if we just put a few elements up, I'll just change the colour to black. So at the top we'd have potassium. Do that in a second. So we'd have potassium at the top, and then underneath that we'd have things like sodium, calcium, magnesium, aluminium. There's aluminium. I'm going to put another non-metal, I'll just put it to the side there, carbon, because carbon plays a big role, zinc, iron, and I'll just end it with tin there, and copper, put copper at the bottom. So if I just show you the order of reactivity, if you will, so the reactivity increases in this direction, increases there. Okay, and these compounds here, because these are the most reactive of the elements, these are usually extracted using electrolysis. So I'll just take a copy of that. Okay, and these compounds here, and iron's one of them, so we've got the iron oxide up there, is usually extracted using what's called a chemical process. Okay, so I think it's probably a good idea to just memorize this reactivity series, and then we'll go on to the next tutorials, which will show us how we can use carbon to isolate these elements, and also we'll look at some methods of electrolysis for isolating some of these elements. We've already looked at aluminium in the previous tutorial. So that's it for now. Bye for now.